Day 43, Honors Physics, Simple Machines, problem number 51. Here we have a dentist chair with the given information. In red here I have all the equations. This is one good technique for solving these problems. The biggest issue you're most likely to have is like what goes where. There's so many numbers going around here and so many concepts it seems. So I've summarized them again with the four equations. A reminder also that these are all ratios, so there are no units involved with the efficiency or with the mechanical advantages because all the units would cancel out. However, for the inputs, the distances and the forces and the work, those all do have units, but they would cancel out when you do the calculations. All right, so another reminder is that the AMA, the actual mechanical advantage, sorry about that, is the load you're lifting divided by the effort you're putting in to lift that load. So I've kind of outlined that in blue over there. And also efficiency, bottom right here, is that the energy output, or the workout, is the same as the energy you get out of it. The increase in energy. And here in this case, this guy is going to gain, or this person is going to gain GPE. The energy input's the work done by the person pumping a pedal. The bottom line is here's what I'd like to do. I'm going to read through this. It says the dentist, dentist has a downward stroke of 20 centimeters when they push on the pedal. Well, that's the distance input. All right. And the force that they're using is 40 newtons. That's the force input. If the device is 80% efficient, so we know E, circle that. So I'm just going to circle things and you'll see what happens here. How many times must she push down on the pedal to lift an 80 kilogram patient? Well, the 80 kilogram patient, and we're assuming the chair, we're ignoring the weight of the chair, so I guess the 80 kilograms is the patient plus the chair is our load. So bottom line is we know this right here, the force output, the load you're lifting, 800 newtons. So maybe you can see the progression now. We're trying to figure out now that I guess maybe you don't see, well, look at the 15 centimeters. Where's that go? Well, that's going to come into play later on. That's what might get confusing because we're going to figure out in progression here how high the chair goes with each individual pump because it's not going to go 15 centimeters high with each pump. I mean, check this out. What you will do with this problem. I'm not sure I'm going to do the whole, well, I'll start off doing the thing. So I'm going to start with this equation right here, okay, because I can figure that out. I'll go up to the top here. The actual mechanical advantage in this system is the output force, the load, 800 newtons of weight that you're lifting, divided by the effort to put in. Well, that's pretty easy. The AMA is 20. You have a mechanical advantage of 20. So just loosely speaking, it's only going to go, the chair is only going to go up 1/20th of the distance that you put in. But you're using 1/20th of the force if we have the ideal situation here. But we do have some friction because this thing is only 80% efficient. So now we look at, we got AMA. I'm going to come down to the bottom left over here. Now I know the AMA. All right, well, I can now figure out the TMA using this equation in the lower left. So I will do that. I have the efficiency of 0.85, 0.85, no, 0.80, equals the actual mechanical advantage, 20, divided by the theoretical mechanical advantage. So now that will give me the TMA, which, sorry about that. The TMA is 25. All right, so now we have the TMA. So going back over to the equations once again. All right, I now know this is 25. So bottom line, I'm going to plug into that equation right there because I know my input distance now is 20 centimeters. So if I get to this equation right here, plug in my TMA, well, I'll do it. Okay. 25 equals your input distance that the dentist is pushing with is 20 centimeters. Let's leave this in centimeters for now. divided by the distance output. So your output distance with each pump is 20 divided by 25, which is 0.80. Now that is centimeters. That's a distance. That's how far the chair is going to go up every time she pushes on the pedal once. So the question is, and I'll leave that last step for you now, if it raises this much with each pump, and she's got to raise a total distance of 15 centimeters, how many times does she need to pump the pedal? That's the question. So there's one more step left for you to do. Good luck.